Hello everyone, once again. Last two videos was about finding out the vector equation of line and doing some examples based on vector equations of line. So next topic is intersection of two lines. So we directly jump to the question that how to solve if it is asking about the point of intersection of any two vectors given in equation form. So question is that we have to find the position vector of the point where the following lines will intersect, right? So as if you recall, in the Cartesian system, you have been given two lines. Let us say x plus y is equal to 2 and 2x minus y is equal to 4. Okay, so two straight lines, so their point of intersection means whatever points you are getting, those 2 points will satisfy either of the two equations, right? So what you do is you substitute, right? If I say that if I take two equations, for example, x plus y is equal to 2 and 2x minus y is equal to 4. So what you do is if these are the two straight lines, then the point of intersection will satisfy these two equations, meaning that if I substitute x as 2 minus y in this equation, right? So you will find out the value of y, right? That means I will equate both the equations. That is the meaning of finding out the point of intersection. So similarly, in vector form, if you have to find out the position vector of the point of intersection, that means put these position vectors equal to each other, right? And from there you find out the value of lambda and mu, means for what values of lambda and mu these 2 points are equal, the position vector of these two vectors are equal, right? Remember, if one line is like this, I'm talking now in terms of vectors, okay, and second line is, let us say, like this, okay, and these are intersecting at this point, meaning is that the position vector of this point, suppose this is your origin, so position vector of this point of intersection, let us say this point is P, will satisfy both the equations, right? Position vector of this point of intersection will satisfy line 1 and line 2, okay? That means I can equate the position vector of these two, and from the solving these two, you will find out the value of lambda and mu, right? Meaning for what value of lambda and mu, these two are the same position vector, right? So we have to find out those values of lambda and mu, and putting those values back into the equation, you will find out the position vector of the required point of intersection. Okay, so we have been given vector r as 2 by 2 comma 3 plus lambda times 1 and 2. This must be equal to 6 by 1 and mu times 1 comma minus 3 plus. Okay, these two are representing for some values of lambda and mu the same position vector. That means 2 plus lambda, and this is 3 plus 2 lambda. This is your position vector r1, you can say this is r2, and this must be equal to 6 plus mu and 1 minus 3 mu, right? So we have two coordinates, one is x coordinate, one is y coordinates. I can equate both these, so I will get the value of lambda and mu. So that means 2 plus lambda is equal to 6 plus mu. From here I get lambda minus mu is equal to 4, and equating the y coordinate, this is 3 plus 2 lambda must be equal to 1 minus 3 times mu. That means 2 lambda plus 3 mu is equal to 1 minus 3 is minus 2. Okay, so we have two variables, two equations we can solve. Let us multiply this by 2, right? That means 2 lambda minus 2 mu is equal to 8. I am using the elimination method and subtracting equation, let us say this is 2, this is equation 1, subtracting equation 2 from 1, I will get 5 times mu is equal to minus 10. So value of mu is minus 2. Putting this value mu as minus 2 in either of these two equations, you will get lambda as 4 plus mu. That means lambda is 2. Okay, so lambda is 2, mu is minus 2. So my position vector of the point of intersection will be, let's put this mu and lambda in, let us say, equation 1. Okay, so 2 and 3 plus lambda times 1 and 2. So let us put lambda in this. So this, your required position vector will be 2 plus 2 and 3 plus 2 into 2. I am putting the value of 2 in this equation, in this vector. Okay, that means it is 4 and 7, right? So this is your position vector of the point of intersection. Okay, let us take another question. It says that in this question, the origin is taken to be at the harbor, and the unit vectors I and j, they to have lengths of 1 kilometer each in the direction E and N. E stands for east direction and N stands for north direction. That means vertical I am taking as j component, which is y, and this is along the x component. So I component is along the east direction, means the x direction. Okay, so there is a cargo vessel which leaves the harbor, and its position vector t hours later is given by this vector. Okay, so suppose there is a cargo vessel denoted by C, and this is the origin. Okay, so we have a position vector r1 for this cargo vessel. Then it says that there is a fishing boat is trawling nearby, and its position at time t is given by r2. So let us say we have a fishing boat f. Okay, so it has the position vector as r2. Okay, so this is your r2. This is your origin, means origin is at the harbor, right? All right. So it says that how far apart are the two boats when the cargo vessel leaves the harbor. Okay, so this origin is your harbor. So how far are these boats, means this fishing boat and the vessel, means we have to find out vector CF mod. Okay, so vector CF mod is, okay, CF we have to find out, not CF, I'm sorry, we do not have to find out CF. It says that how far apart are the two boats when the cargo vessel leaves the harbor. That means when the cargo vessel is leaving the harbor, that means at t equal to 0, we have to find out the distance between two. Okay, so at t equal to 0, this cargo vessel is at the harbor only, right? So if I put t equal to 0 in position vector r1, here you put t equal to 0, you will get r1 as 0. Okay, that means this cargo vessel is at the origin, and r2 will be at t equal to 0, 10 I cap plus 8 j cap. Right, so at t equal to 0, CF is just OF. Meaning is this, that C reduced to this O, because at time t equal to 0, again I am repeating, the cargo vessel is at the origin, at the harbor. Right, so we just have to find out mod R2 when t is equal to 0, which is 10 square plus 8 square under root. So it is 164 root. Okay, kilometers you can write, because all these units are in kilometers. Fine, so this is your first part. Now second part says that how fast each boat is traveling. So I think in vectors there is no differentiation involved as far as your syllabus is concerned, but yes, we know how to differentiate, or we know the meaning of differentiation. This we have already done. I think you have also done in class 11th and class I think in IGCSE also. That rate of change of the position gives you the velocity, right? So if I have to find out the velocity of cargo, right, so I will differentiate r1 with respect to t. This will be your velocity of cargo denoted by vc. Okay, so this is 12 I cap plus 16 j cap. Okay, 12 I cap plus 16 j cap, and if I have to write down the modulus or the speed, so it's just say that in the x direction speed is 12 meter per second, not meter but kilometer per hour, and in y axis the speed is 16 km per hour, right? So if I have to find out the modulus, then we have to take the root of this, means 144 plus 164 root. So it is 20. So 20 km per hour is the velocity or the speed of basically velocity. If I have to find out the if vectors are given, so velocity is the right word, right? And for cargo 2, d of r2 by dt, not the cargo 2 but this fishing boat. So okay, so now we have to differentiate this r2. So 10 is a constant, so it will be minus 3i cap plus 4j cap. This is your velocity of boat, right? So velocity of boat magnitude will be 5 kilometer per hour, right? So basically, if you differentiate the position, you will get the velocity. And if you differentiate the velocity, you will get the acceleration. Since velocity now is a constant, there is no t involved here. So that means there is no acceleration. They are moving with a constant velocity. Okay. Now third is what happens, right? So what do we mean by this? What happens is that after what time and these two vessels are intersect, they will intersect or join, or they will collide. Okay, why I'm saying that these are colliding? If you see that the velocity of r2 is minus 3i plus 4j, if you look here closely, if I take the vector diagram, that it is moving in the negative x direction and positive y direction, right? Means it is moving towards the west and north. So direction is northwest, right? So this cargo 2 is traveling in this direction. Okay, and not cargo 2, boat is traveling in this direction, and this fishing boat, right? And the cargo velocity is 12i plus 16j, right? That means x is positive, y is positive, so it is moving in northeast direction, right? So velocity of the cargo is like this. Okay, it is like this, meaning in northeast direction, right? So after some time, definitely they are going to meet, and this we have to find out whether they will collide or not, right? Because they are crossing perpendicularly, right? So we will see that will there be any time such that both of these will collide or not, right? So if they are colliding, if they will pass each other, not colliding, if they pass each other, that means at that very instant, if I extend this boat to this point, that means at this very instant, both the boat and the cargo vessel, they have traveled the same time, they have traveled through the same time. I'm not saying that they have traveled the same distance, because of course the velocity is 4 times, velocity of this cargo is 4 times of this boat, so it is traveling faster, right? So at this moment, at this instant, both the boat and the cargo vessel, they are traveling through the same time. So that means if time is same, and their position vector will also be same. Okay, their position vector will also be same, right? If I'm talking about the position vector, taking the reference as the origin forward, so at that very instant, position vectors are also same. And if the position vector are same, so let us say at what time they will intersect or they will collide. So marking this or taking r1 is equal to r2, making both the position vectors are same. So let us equate these. So r1 is 12t plus 16t, t I cap plus 16t j cap. This is equal to this is 10 minus 3t I cap, and this is 8 plus 4t j cap, 4t j cap. Okay, if these has to be same, that means x component should be equal to x and y component should be equal to y, right? That means 12t must be equal to 10 minus 3t. And if I find out this from here, value of t will be 10 by 15, which is 2 by 3 hours. Now, if we have to find out whether they will collide or not, right? So this same time t, which is 2 by 3, that must satisfy the y component. So if I equate y component, which is 16t equal to 8 plus 4t, and from here also if I find out value of t, which is 12t is equal to 8, so it is 8 by 12, so again it is 2 by 3 hours. So what you have noticed here, that both the equating the x component and y component, time is coming out to be same. That means they will collide, and when they will collide, position vector will remain same. And at what time they will collide? It is 2 by 3 hours. So if you have to convert these into minutes, so it is 40 minutes. So what you have to write in the answer is that after 40 minutes, both the cargo vessel and the fishing boat, they will collide. And also you can find out the position vector also by putting t as 2 by 3. Okay, by putting t as 2 by 3, you will get the position vector. Okay, so that's all for intersection of two lines. In the next video, there is a last topic, I think, the finding out the angle between two vectors, angle between two lines, not the vectors, and lastly is finding out the shortest distance. Okay, see you in the next video. Bye.